The U.S. Army Engineer Research and Development Center, or ERDC, develops and maintains a world-class data analytics capability comprised of high-performance computing hardware and software platforms for large-scale analytics, as well as a team of highly trained data scientists. Researchers with the Program for Advanced Materials and Substances of Emerging Environmental Concern, or AMSEEC, also use advanced artificial intelligence, AI, and machine learning, or ML techniques to automate labor-intensive and error-prone data management tasks.
Artificial intelligence is an algorithm set that is designed to take large amounts of data and approximate what the result is, not based on physics, but instead based on experience. So it takes what it knows from training data sets of these whole big set of random inputs, ends up resulting in this. Think of it kind of like, the weather, I don't know why I know this, but it's going to get slightly overcast and a little hotter later this afternoon. Maybe it's the wind or the bugs or the way the flowers are, I don't know. But because I've lived here long enough, I know that that's going to happen. Same way with the AI and ML algorithms. They have all these little tidbits of information about the molecules, and okay, they've seen something like this before, so they know that it's going to partition this way in the soil, or it's going to cause this adverse outcome for toxicology on our fish, or something like that.
Some of the processes include collection and analysis of large data sets required for development and application of computational models to predict effects of contaminants, tracking the movement of chemicals through complex environmental matrices, and evaluating possible degradation pathways to inform development of new treatment technologies.
So for PFAS in particular, there are so many of these compounds, and depending on which definition you use, there might be tens of thousands, there might be 100,000. And there's just not enough time to do all those experiments to know where it's going to go in the environment, how fast it's going to evaporate, or is it going to stick to soil, will it go to the water? So we can predict some of these properties for some of these molecules, but that's still not enough. How do we pick the best set of molecules to get the best representative data? And so that's where machine learning comes in. Maybe we find, and we have done this, novel classifications of PFAS. We can just take a few from here, a few from here, and get representative data with as few calculations as possible.
Additionally, these tools can be used to facilitate the collection, curation, and analysis of large repositories, greater than 20 terabytes of published data and other information, to uncover patterns and relationships that might not otherwise be identified.
Every time we do a data assessment, or anytime we do a computational model, that's building a framework that we can use moving forward, right? So we're not starting from ground zero. Furthermore, as we start building these foundations, we can refine, we can improve, and we can just get better and better.